Hey guys, this is Patrick from STH. If you haven't heard by now, AMD just bought Pensando for $1.9 billion, or at least they announced the acquisition. And I'm sure that today we're gonna have a lot of folks that are gonna ask, number one, what's a Pensando? Two, why did AMD spend $1.9 billion-ish on it? And that is the topic of today's video. So the quick answer is that AMD decided that Pensando is their answer to the DPU market. Now, DPU market is still relatively new for a lot of folks. So if you haven't heard about a DPU and you've maybe heard about a CPU, a GPU, FPGAs, you've heard about AI accelerators, all that kind of stuff, but what in the heck is a DPU? Well, it turns out that we actually have a video on what is the DPU that you can go check out, and it's still very relevant today. And we have another one talking about the STH NIC continuum, so the network interface card continuum. And basically the idea is that we go from a pretty basic NIC all the way through. We go through what an offload NIC is, a smart NIC, we go to a DPU, we go to exotic types of things. So we talk about all these different types of NICs and what kind of really are the differences between them. And in our What is a DPU article, we actually talk about Pensando and talk about their architecture and what makes that a DPU versus not a DPU. So we do have this entire thing already done on STH, but what we'll do as a very high level, we're gonna talk about a couple things that make a DPU versus like a smart NIC or something else. So the first thing is that you need high-speed networking connectivity. Anything below really like 100 gigabits per second, really that was kind of like the cutoff for when we started seeing DPUs. We do actually even have a Bluefield 2 DPU that runs at 25 gigabits per second per port, but realistically, the vast majority of them are 100 gigabits per second or higher. And since we have a ton of them, I'm just gonna use the NVIDIA Bluefield 2 DPU, and you're gonna see that we have two 100 gigabit Ethernet ports. The second thing that a DPU needs to have is high-speed packet processing. And normally that'll be programmed using some kind of, like packet processing language, something like a P4 or P4-like kind of environment. And so that's another thing that we typically will see on DPUs. Also, there's a CPU core complex. So not only have we looked at a couple times logging into one of these Bluefield 2 DPUs, it runs Ubuntu just kind of like a server. We actually even had the cluster video that we did with a whole bunch of these. Actually, I think we had 7 of them in a AMD Ryzen Threadripper Pro system. And so, we had that entire little mini cluster in a box. And there we kind of showed that there's ARM CPU cores on these DPUs, and then also it's running its own operating system. Now, there is a vendor that does use MIPS. We'll get to that in a little bit, but as we're going to see, Pensando is actually an ARM CPU-based solution, although the ARM CPUs are not necessarily the main focus of the entire card, but we'll talk about how those are used in a little bit. So you need to have memory controllers, and these cards all have their own memory. Bluefield 2 doesn't necessarily have very fast memory interface at all, but you can actually see the DDR packages on the back here. The other thing they need to have is accelerators. We'll almost always see crypto offload, and sometimes we'll see other things like compression offloads and other types of offloads as well. And so these accelerators are really hardware accelerators that are really required for a lot of the activities that these DPUs are doing. The other thing that you typically will see on these DPUs is the ability to have at least PCIe Gen 4, and then also to be able to run the PCIe Gen 4 as either an endpoint, so where there's a host system and that's being run as an endpoint, or as a root. And we're going to show you exactly how to go run and why running a DPU as a root is so powerful in a video. I think we're going to do it probably in the next week or two using these Bluefield 2 DPUs. And I know I'm kind of plugging Bluefield 2, but we just have a ton of content coming out with those. And so that's just something that I think is really powerful. And I'm going to show you how that all works, and we're going to explain that, and I'm literally going to show you. So definitely subscribe and turn on notifications so you see when that video comes out, because it's super cool. I've been working on it for like 3 months, and it's just awesome. Usually you'll also see things like management features and also security. So you see things like a hardware root of trust in the kind of newer generation DPUs. In terms of management, I mean, this thing actually has like an out-of-band management port just for the card itself, not even including the 200 gig ports. And finally, they all run their own OS. And this is super important that they are not using the host OS from the host system. They have to have their own OS. Okay, so that's what a DPU is. But what's a Pensando, and why the heck is AMD buying one of these, like a company that makes these cards and this kind of stuff? Well, there's a couple things there. So first off, Pensando is a company that was founded by some folks that used to work at Cisco a long time ago, actually, with my father back in the late 90s and early 2000s. So the one thing to think there is that these are folks with definitely a big network background, right? And Pensando's physical card is called their distributed services card. They don't call it a DPU, but honestly, we can't have everybody call everything their own thing. I mean, everybody can call their stuff whatever the heck they want, but we need to go and kind of put these in buckets so if somebody can think like, okay, if I would need something that's like a DPU, well, what are my options? If I need something that's like just an offload NIC, what are my options? So we have to kind of put these in buckets so they can say distributed services card, we're going to say DPU, and that's the translation layer. But basically, on the card itself, it actually has a P4, so programmable pipeline to go do packet processing, and then there's a whole core complex memory controllers. It runs its own OS. There's also offloads for things like crypto. They also have storage offloads and just like a whole bunch more. So there's definitely a lot going on here. And we'll have the block diagram for their 7nm elbow part that we'll put up. And you can basically see kind of all of the main parts that I just described in this diagram. And although it's probably, frankly, less relevant for this acquisition, they did have a previous product, which is a 16nm product called Capri. But I don't necessarily think that Capri is the reason that AMD is purchasing Pensando. I think it's really the software, so the technology behind getting these cards to run and be useful. Also, some of the IP that they have in terms of their engines, and then also, Elba was basically prototyping. Prototypes were out like 2 years ago, and Capri was 2 years before that. And so I wouldn't be surprised if, Pensando has another version at some point coming out and AMD like what they saw. So the big thing here, though, is just when you have a very fast packet processing pipeline that's customizable, and then you have accelerators that you can go and utilize, what you basically can do is take a lot of the logic and a lot of the stuff that the people were trying to figure out how to do in switches and actually move that onto the card itself and then manage it for the host in relation to all the VMs, like all in the same box-ish. And so the other way to just kind of think about it conceptually, if you are familiar with this, is actually the AWS Nitro cards. Now on STH, we actually did an entire piece on, and I think maybe actually a couple pieces on the AWS Nitro. AWS bought a company called Annapurna Labs a long time ago. We have done reviews of some products with Annapurna Labs chips because Amazon actually does sell those externally. But in terms of their actual Nitro card, that was something that AWS did, and it was like completely revolutionary in the industry. And basically what AWS has with their Nitro-based instances, which is most of them these days, is they actually have a Nitro controller. And that Nitro controller is handling tasks like doing all the networking. It handles bringing things like EBS and storage into the box. It handles a lot of the hypervisor and like management functions and all that kind of stuff. So when AWS deploys a server, they have that Nitro NIC in the server, accelerator, whatever you want to call it, in the server, and they're able to go and use that as their endpoint and then provision the server and any of the virtual machines that are on that server using resources from the overall AWS cloud. And so that's how Magic's if you want the have a VPC or something like that, that's how AWS is part of the solution for AWS to manage having VPCs and being able to connect things even if they're not not necessarily next to each other in racks and stuff like that. And so that same idea of having a card that you can go put in a server or other boxes, and we'll probably get to that on STH in a little bit. But you can basically put this into a box and then manage all of the resources that are in that box using the DPU. And that provides things like you get better security because you can do things like you can encrypt all the traffic and then keep all the traffic encrypted and separated as it leaves the actual network ports. You can also do things like you can provision storage and bring high-speed storage into the various virtual machines. You can do things like bare metal server provisioning because you're basically presenting devices over the PCIe portion of the card, and so you can actually decide what you want to go present. And one thing that we're going to show is actually how you take NVMe storage and present it via DPU to a server without actually having the NVMe storage in the actual server itself. So that's super cool. But of course, if you're going to bring a whole bunch of different resources to a box, and then you have a whole bunch of virtual machines that you may or may not necessarily trust anything that's running on those virtual machines, and you have to manage that, well, that's why you have a DPU to be able to manage both sides of that equation. And so that's really the whole point of this. And just in the industry, when we talk about it, right, we have NVIDIA with the BlueField 2, we have Intel, which has Mount Evans, which is what Google Cloud is using, and then they also have some IPU solutions, which are more like exotic, and we'll take a look at those actually in a couple weeks. But those more exotic IPU solutions that have like FPGAs and Xeon D and stuff like that, those are definitely for other cloud providers. We actually have Marvell with the Octeon 10, which is just an absolute killer thing. Haven't been able to get one yet, but they are, from everybody that has used them so far, I've heard that they're very, very good. So I'm very excited about those. And then, of course, you have AWS and other cloud providers kind of working on their own things. And there are some other providers out there like Fungible. Broadcom had a Stingray thing going on for a while. And so there are a whole bunch of DPU providers, but basically AMD really didn't have it. I mean, they had Xilinx, and Xilinx can kind of compete more in that like exotic category against maybe some of the IPUs that Intel has. But when it comes to having like that ASIC that is this DPU class ASIC, AMD didn't really have anything. And if you think about it, no matter what you have, whether it's accelerators or CPUs or anything, you're gonna need something like this. And speaking of Mount Evans and Intel, if you actually go look at the Mount Evans slideware that we actually covered on STH, what you'll see is that they're also talking about their P4 programmable pipeline in Mount Evans, right? So this whole P4 thing is not just a Pensando thing. This is in, many different vendors are using it these days. It's a pretty big industry trend, right? And so that's kind of really where Pensando said like, hey, this is an efficient packet processing engine. It was programmable. We want to have this. Let's go build on top of this. And I think that was really to their benefit at this point. So why is AMD buying Pensando? I think the answer is really simple. If you have NVIDIA and you also have Intel as competitors and they're able to offer DPUs, well, you probably want to be able to offer a DPU as well. And Pensando has something that actually is very different, especially from the Bluefield line right now. And so I think that is definitely a pretty valid way to go about it. And you could totally say like, hey, now that AMD has Xilinx, doesn't Xilinx have good network people that like could be used? They could do something like this. And you're probably right that maybe you could go build a team and then that team could go build something. But you also just may need to have a solution sooner, and you want to de-risk the engineering side of that. And so going and buying Pensando, I guess, makes a lot of sense. But the funniest thing was that I was actually talking to Fungible, which is another DPU maker that really started on the storage side, and now they're trying to branch out and do other devices. But we'll have a piece on Fungible, and I was talking to them about something that's going to be later on STH this week. But at the same time, I was telling them, I was like, hey, you guys need to go and work with like everybody's devices, because if you start working with a whole bunch of different players' devices, then you're not the NVIDIA Bluefield that like NVIDIA is going to definitely push for Bluefield or for NVIDIA-based AI instances and all that kind of stuff. Like NVIDIA has a market that they have in mind for Bluefield. Same on the same side, Intel, they have their accelerators, they have AI accelerators, GPUs, they have all kinds of stuff, and right, they're going to go put that onto their Mount Evans DPU or their IPU or their other IPUs. So like that's that ecosystem, and if you want to kind of play and maybe you want AMD to like look at you to go buy, well, you should probably go and try working with a whole bunch of different devices. And then a couple days later, I was briefed on the fact that they were actually going to be AMD was actually going to be buying Pensando. So it's going to be kind of awkward a little bit later today, but that's happening. And kind of thinking about now what AMD has in the data center, I mean, they have some really cool things, right? I mean, just think about the high level what they have. They have the AMD EPYC CPUs, so that's basically their processors, right? And then they have the Instinct GPUs. Now, the Instinct GPUs are actually very, very high performance. There's actually a picture of me in Calgary with a Cool IT Systems, and it's a Cray EX, so supercomputer node that actually had a whole bunch of, so there's like 8 MI250Xs, which have like 2 different dies, and each die has like 4 HBM stacks. I mean, super high-end chips. And those chips are actually going to compare very well to Hopper that NVIDIA just released. So, I literally had this just giant supercomputer node, liquid-cooled supercomputer node in my hands, but they have these accelerators that are really for high-performance computing. And they don't even necessarily talk about their accelerators. They kind of talk about it as GPUs, but they're becoming, very distinct from the line for desktops and workstations and stuff like that. I mean, they use CDNA architecture, and they are really high-performance computing accelerators at this point. They're not really like GPUs, right? Or at least traditional GPUs that you would go put in a gaming PC or something like that. And now that Xilinx is part of AMD, I mean, Xilinx brought the FPGA logic. They have awesome transceiver stuff. They have, high-speed networking things. They have, a pretty wide range, like from little embedded parts to pretty high-end data center parts. So they have all kinds of different types of devices that you make there. Not only do they have the programmability, but they also have accelerators for things like video. They have crypto accelerators. They have AI accelerators. I mean, they have a ton of different types of acceleration technology in the Xilinx portfolio that now, well, I guess AMD has. And AMD also has SolarFlare, the fruits of the SolarFlare acquisition that Xilinx made prior to AMD's acquisition. So, I mean, the Xilinx folks actually bring a pretty wide breadth of products into that data center portfolio. And frankly, at this point, the one thing they really need is just some kind of networking solution. Like, for example, the AMD EPYC 3000 series, we did a whole series on the EPYC 3000 series, which is the embedded EPYC. And it's one of those ones where, I mean, it has onboard 10 gig Ethernet. And in fact, even the Naples generation, so if you look at the EPYC original idea for EPYC was that you actually had 10 gig Ethernet coming directly from the CPU. But it turns out that AMD's 10 gig Ethernet IP was, how do I put this gently? It was functional, but it didn't necessarily have all of the functions that people came to expect by the time those products really came to market. So if you just needed a just pipe and you don't really care about having a whole bunch of different features that are kind of common in the data center place these days, then AMD's IP was totally okay with that. But when you kind of went to higher end virtualized solutions and stuff like that, they're just features that the onboard NICs that were on those chips, they just didn't have, right? And so that was just an example, I guess, of the fact that AMD just needs help on the networking side. And frankly, going after the offload NIC or the basic NIC is probably not really where AMD's sweet spot is. And so I guess what AMD said is, well, we're going to go after the higher end solutions. And I think that makes a lot of sense because in the future of data centers, we're going to see a lot more composable architecture. The idea that you can have a box full of storage, like NVMe storage, and you're not going to necessarily need a CPU in there. You can just have a bunch of storage connected to a DPU and then provision it using the DPU. We literally have that demo working, and we have the video on that'll be coming out in the next couple weeks using the NVIDIA solution, right? So AMD needs something like that because that's a different class of processor. It doesn't necessarily use the EPYC processor or Xeon processor or anything like that. It uses these kind of ARM-based DPUs. Likewise, if you think about the accelerator space, right? You have a whole bunch of this whole virtualization farm, right? You have a whole bunch of servers, but you don't really want to put necessarily a whole bunch of GPUs in each server. And there are a lot of tasks where you can actually push a lot of data to the GPU at once, or you can stream data to a GPU. GPU can work on it and just kind of funnel back results. So you're not doing a ton of IO over PCIe. And so when that's the case, you can actually get pretty good performance by even having remote GPUs and then funneling them through a DPU and presenting them to a system. So the idea that you could just have kind of your normal 1U server or 2U 4-node server, whatever it is, and then you could just go have a DPU attached and you can go out over the network and add a whole bunch of storage. You can go add a whole bunch of GPUs, even more GPUs than you could get in a physical box. You could go get 16 GPUs or 32 GPUs, whatever you want. You can go get all those kind of things using a composable infrastructure. And I think that that's really kind of what AMD is focused on now. And so that's just kind of my sense. And by the way, I did talk to both execs from AMD as well as Pensando before the acquisition, so I have some idea of what these guys are thinking at least. I also frankly think that AMD really needs to go figure out an AI story because they need something in that space ASAP, and so hopefully they're going to come out with something soon. They didn't tell me anything about that. I'm just kind of saying that it feels like that's the next big hole in their portfolio. And then the other thing to just remember is that in the future generations of processors and server processors and things that we see in the data center, the idea of having kind of a base chip and that's kind of all you get is just x86 chip, and that's just maybe you get some cores, you get some cache, some IO, and that's basically it. Those days are probably going to be behind us to a large extent, especially for large hyperscalers. Recently, we saw the Universal Chipset Interconnect Express, which is UCIe, and that is basically a way for a whole bunch of vendors, it's across a whole bunch of different vendors, how they can go and create interfaces to go and put a whole bunch of different little chiplets onto a single package, and that's something that the cloud guys really want, and we're going to see some absolutely wild chips. It's not necessarily something that I'm expecting to see a lot of just crazy wild stuff later in 2022, But in the next couple years, we are definitely going to see a lot more, I mean, just absolutely cool designs, but it's also going to mean that a server chip between like different cloud providers and, you know, what you buy in the enterprise and like all these different things are actually going to be tailored more for specific applications than they have been previously. So we're about to get to a total different era in terms of chips, and that's what the chiplet revolution is going to bring us. And so for that, you could definitely see why you might want to have things like a high-speed network engine that can bring in resources from the network and be able to integrate that potentially in the future with something like Pensando IP. So I think what AMD is really doing is they're really buying all these IPs, or they're building or buying all these IPs that they really need, and they're going to have a whole bunch of IP blocks, and then they're going to say, hey, you know, we can go do our integration, we can go have our IP blocks, we can go get IP blocks from other folks, we can get, you know, pieces fabbed from different things, and we're going to go start putting things together. And I think that's also what we really saw with the 3D V-Cache. So we just did the AMD EPYC 7773, or 773X. And that part, you know, has a 3D V-Cache, has 3/4 gigabyte of cache. And really, that's just kind of showing that AMD can do 2D and also 3D packaging. So I think that, you know, when we really look at where these chips are going and why AMD bought Pensando, it starts to make a lot more sense as AMD is building out their portfolio. So one of the first things I know I'm going to get asked today is like, you know, $1.9 billion, was that worth it? Frankly, I think, yeah, I can totally see why it's worth it. It's a pretty high valuation, but all valuations for tech companies like this are pretty darn high these days, so I don't think you really have a choice. And then AMD basically had their choice of buying Fungible, or they would have to basically buy Pensando. And so they decided to buy Pensando, which I think actually makes sense, especially when you kind of look at the rest of the AMD portfolio and what they've been doing over the last couple of years. So I totally get why they would go buy Pensando, and that makes sense to me. Price is definitely not cheap, but also I guess that makes sense as well. I think, frankly, the bigger question for me right now is like, what happens to Fungible? Because Fungible is now the kind of like lone DPU company that's just kind of like out there. They use MIPS instead of ARM. And, you know, like, does Broadcom say like, hey, Fungible, what's up? Or somebody else, maybe somewhere not in the US, somebody goes and buys them. I don't know exactly what happens to Fungible after, but it just kind of feels like they need a dance partner because, you know, you have Intel, AMD, NVIDIA, Marvell, all with solutions. And I guess there's a Broadcom Stingray thing, but that really, we're not going to talk about that. But overall, I think congratulations are in order. I mean, you know, Pensando basically built this company. A good part of its life was basically during this whole pandemic thing. And here they are with a $1.9 billion exit. I mean, definitely congratulations to that team. Another great exit. And finally, I've definitely mentioned this a couple times, but we actually have an entire series going through different types of DPUs and showing you some use cases, because we've actually had them set up and we've actually been running some use cases on them over the last couple months. And so I think we're going to start showing that off probably in the next 2 to 3 weeks or so. And I'm actually going to go film some more stuff on that pretty soon, doing a trip this week. So we're definitely going to have a lot of DPU content. I really hope that we get some of these Pensando NICs once they get acquired by AMD formally, and we can hopefully actually get parts, because I've been promised parts for a while and I really want to go and test these out and show you guys. But overall, I think this is a great day for AMD and really cool development in the world of DPUs. And hey, if you like this video, well, why don't you give it a like, click subscribe, turn on those notifications so you can see whenever we come out with great new videos. As always, thanks for watching. Have an awesome day.